Hi, this is just some acceleration practice questions, part of the mechanics for A-level physics. If you want to have a go at them, just feel free to pause, have a go at these 3 questions, and then I'll take you through the answers. So the first one, the handbrake of a car fails and it rolls down a hill of length 20 meters in 8 seconds. Calculate the average velocity as the car goes down the ramp. So the first one, the average velocity, is simply the, oops, I don't know why I did that. Get rid of that. Velocity would be the distance travelled or displacement travelled divided by time taken. So that would simply be 20 meters divided by 8 seconds. So that gives us 2.5 meters per second. Okay, now the next one, the speed of the car as it is at the bottom of the ramp. Now you might think, well, if the average is 2.5, then the final velocity is just double that, which would be 5. But let's prove that. So let's write SU that, and let's take down the ramp as positive. So the displacement down the ramp is the 20 meters. The initial speed is 0. The final speed is what we're looking for, V. The acceleration is unknown, and the time taken is 8 seconds. So there's an equation of motion, it's on the data sheet, so that would be S equals half U plus V times time. So we need to rearrange to find the final speed, the V. So that would be 2S. It would be 2S is equal to, that would be the U plus V times time, and then obviously divided by time. So it would be 2 times the displacement, which is 40, divided by the time taken, 8, and that would be equal to U plus V. But the initial speed, obviously, or the initial velocity is 0, so that would be equal to the final velocity V. So that would be 40 divided by 8 is indeed 5 meters per second. Okay. Hopefully that's all right. And then part 3, the acceleration of the car down the ramp. So part 3. So let's do SU that again. So SUVAT. So positive down the ramp. So the displacement is 20 meters. The initial speed 0. Final speed we now know is 5 meters per second. The acceleration is what we're looking for, and the time is 8 seconds. So we could simply use V equals U plus AT. So V equals U plus AT. So I need to rearrange to find the acceleration. So its acceleration is change in velocity divided by change in time. So the change in velocity is 5 divided by the change in time, which is 8. So the acceleration is simply 0.625 meters per second squared. Okay, hopefully that one went okay. All right, I'm going to get rid of that, and then let's have a look at question 2. So question 2, an antelope accelerates at 4.8 meters per second squared from rest for a distance of 52 meters. Calculate the final speed. Right, okay, so let's do SU that. Let's say the antelope is running to the right, and right's positive. So the displacement is 52 meters. The initial speed is 0 because the antelope is initially at rest. The final speed is what we look for, V. The acceleration is given as 4.8 meters per second squared. And the time taken, we don't know. So we need an equation without T in it. So that would simply be V squared is equal to U squared plus 2AS. And we need V. So V is equal to the square root of U squared, which is 0. So it's just the square root of 2 times the acceleration times the distance or displacement, which is 52. So if we do 2 times 4.8 times 52, and then square root the answer, that should give you 22.3 meters per second. Hopefully that one went okay, relatively straightforward. And then let's have a look at, to finish, question 3. So question 3, electrons in a particle accelerator are initially moving at 8 times 10 to the 3 meters per second. It accelerates to 6.4 times 10 to the 7 meters per second in 6 times 10 to the minus 6 seconds. So calculate the acceleration and then the distance traveled in this time. So for part 3, what we'll do is just write suvat, and we can give the direction that the electron's traveling. We'll just say it's to the right. Okay, let's have a look. I don't know, I've written suvat, so let's get rid of that. Okay, so the displacement is, well, we need to figure that out for part 2, so let's write S. The initial speed, it's initially moving at 8 times 10 to the 3, so 8 times 10 to the 3 meters per second. The final velocity is 6.4 times 10 to the power 7. The acceleration, we're trying to figure that out as well. And then the time taken, the time for that change is 6 times 10 to the minus 6, or 6 microseconds. So let's find the acceleration first. So acceleration is simply the change in velocity divided by the change in time. So v minus u, so that's 6.4 times 10 to the 7. Subtract 8 times 10 to the 3. Divided by the change in time is 6 microseconds, 6 times 10 to the minus 6. That gives an acceleration of 1.1 times 10 to the power of 13 meters per second squared. Hopefully that one went okay. A large acceleration, but it is feasible. And then part 2 is the distance travelled in this time. So we've got suvat again, so we need to find S. And you can basically use any equation that you want. So I'll use S equals a half u plus v times t. And then just put the numbers in. So S is equal to a half, so 0.5. And then it's u plus v, so 8 times 10 to the 3 plus 6.4 times 10 to the 7. And then times that by the time taken of 6 microseconds, 6 times 10 to the minus 6. And if you put that in your calculator, you should get 192 meters. Hopefully that's okay for the first part of this this video. Part 2 will follow afterwards. A couple more questions to do, a little bit trickier. Hopefully you found that okay, and I'll speak to you at the next one. Thank you.